So in this pencast we're going to talk about finding the slope between 2 points, and we generally do this using a formula. And so we have the formula written here. It says the slope of a line passing through the distinct points x sub 1, y sub 1, and x sub 2, y sub 2 is, and then m, remember m stands for slope, so m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, provided that x sub 2 minus x sub 1 is not 0. Remember that if you do get 0 when you subtract your x coordinates, what that's really telling us is that the slope is undefined, because our fraction bar represents division, and you cannot divide by 0. Alright, so it says use the slope formula to determine the slope of the line containing the 2 points. So anytime I'm given 2 points and I'm asked to find the slope, the first thing I'm going to do is label them. So for this first point, I'll call it x1, y1. And for the second point, I'll call it x2, y2. And then I always write down my formula. So m equals y2 minus y1 over x2 minus x1. And now you just plug in your values. y2 is negative 2, so we write negative 2 minus. y1 is 3, so we write in our 3. x2 is 1 minus, and then x1 is negative 2. I always change my subtraction to addition of the opposite, so on top minus 3 becomes plus negative 3. And on the bottom, minus negative 2 becomes plus positive 2. So now we go ahead and do the arithmetic. Negative 2 plus negative 3 is negative 5. And 1 plus 2 gives us 3. So our slope is negative 5 over 3. Now remember that the slope m also gives us the rise over the run. And what we mean is the rise is the how far you have to go up or down. Remember, up if the top number is positive, down if the top number is negative. And then the run is going to be left or right. You go left if it's negative, and you go right if it's positive. And if we have simplified right, then our run should always be positive, because we never want a negative sign in the denominator. So if we've simplified correctly, then we'll always be going to the right. Alright, so by the formula, our rise is negative 5, which tells us that to get from one point to another point on the line, you're going to go down 5 units. And then having a run of 3 tells us that we're going to go to the right 3 units. And that's how we could use this if we wanted to graph. Now we can also check visually. You know, we've done this by the formula, but let's go ahead and graph these 2 points in the Cartesian plane and see if we have to go down 5 units and to the right 3 units to get from one point to another. So if we graph this x1, y1, that's negative 2, 3. So I go to x is negative 2, y is 3, and I put in my point. Now I'm going to go to the x2, y2, so x is 1, y is negative 2. So x is 1, y is negative 2. Now we're going to start at x1, y1, which was our negative 2, 3 point. And if you notice, we have to go down 1, 2, 3, 4, 5. So we're going down 5 units, which is exactly what our slope tells us, and then over 1, 2, 3. So we're going to the right 3 units, and that's exactly what our run said. So we've confirmed that our solution is correct. In example B, we have 5, -1, and -3, -1. So first I'm going to label them x1, y1, and x2, y2. Now I want you to notice too that y1 and y2 are the same. We have -1. Anytime the y values are the same like that, we know we're going to get a horizontal line passing through that y value. And a horizontal line is completely flat, so we should get 0 slope. But let's go ahead and use the formula just to confirm that. M equals y2 minus y1 over x2 minus x1. Now we've got y2 is -1 minus y1 is -1. x2 is -3 minus x1 is 5. Then we're going to change our subtraction to addition of the opposite. So minus and negative becomes plus a positive. And then minus 5, that's minus positive 5, becomes plus -5. -1 plus 1 is 0. -3 plus -5 is -8. So now we have 0 divided by -8. And 0 divided by any non-zero number is 0. So we have a slope of 0, which is what we were expecting. If we were to go ahead and graph these 2 points, we've got the first one is 5, -1. So x is 5, y is -1. And then our second point is x is -3, y is -1. And if we draw a line connecting those 2 points, we can see that it's a horizontal line. It's completely flat. That line has no slope, or 0 slope. Example C is a little bit more difficult only because there are fractions involved. So we are still going to call this point x1, y1, and this point x2, y2. Now in the second point for the x-coordinate we're given 2 1/4. And you don't want to work with mixed numbers really. Let's go ahead and convert that to an improper fraction. So our first point is the same, 9/4, 2/5. But in our second point, 2 1/4, to convert that to an improper fraction, I multiply the whole number by the denominator and then add the numerator. So 2 times 4 is 8, plus 1 is 9. So that's 9/4, 1/10. Now you should be able to see that the x-coordinates are the same. They're both 9/4. So in the last example, the y-coordinates were the same and we got a horizontal line passing through that y value. This time we're going to get a vertical line passing through x's 9/4. Vertical lines, remember, have an undefined slope. So what we should find is that if we try to plug this into the formula, then the denominator is going to be 0 because dividing by 0 is undefined. So let's go ahead and try that. M equals y2 minus y1 over x2 minus x1. y2 is 1/10 minus y1 is 2/5. x2 is 9/4 minus x1 is 9/4. So we can see that we're going to have 9/4 minus 9/4, which is 0. We can go ahead and finish this problem. In the top, in the numerator, remember we cannot subtract without a common denominator. The common denominator is 10, so 2/5 we'll have to multiply top and bottom by 2. That's going to give us 1/10 minus 2 times 2 is 4 over 5 times 2 is 10. And then we've still got 9/4 minus 9/4. So now we have 1/10 minus 4/10. When we're subtracting fractions, the denominator stays the same, and then we just subtract. 1 minus 4 is actually going to be -3. And then 9/4 minus 9/4 is 0. And anything divided by 0 is undefined. So our slope is undefined. So remember, the only lines that have undefined slope are vertical lines. So over to the right, I've drawn a rectangular coordinate plane, and I have not used the normal scale. Normally we would go by ones, but we have fractions here. So for the x's, I had 9/4 and 2 1/4, or 9/4. So I wanted to make sure that the x scale went by fourths. So I have 1/4, and then 2/4, which reduces to 1/2, and then 3/4. 4/4 is equal to 1, and then 5/4, and so on, up to 9/4. On the y-axis, since I had 2/5 and 1/10, I did a scale by tenths. So we have 1/10, and then 2/10 would be 1/5, and then 3/10, and so on. So now let's go ahead and graph these 2 points. X is 9/4, and y is 2/5 in the first example. So you go to 9/4 on the x-axis, and then up to 2/5 on the y-axis. And there's our point. In the second ordered pair, we have 9/4, so the same x value, and then 1/10. And now if we draw a line through those 2 points, we can see that it forms a vertical line which has an undefined slope.